Hello, my name is Ben Ferriolo, and I keep an eye on volcanoes in the United States and sometimes the world. I've been doing this for a little less than a year and have learned a lot. I even have my own website. You're gonna be surprised as to what you find. A link is provided in the description box below, right under my email address. This video is a warning to those who live on the big island of Hawaii. I will present some of my findings via GPS data and a brief overview of reported earthquake activity since January 1st, 2019. This is by no means meant to be a real research video, but is one meant to notify the inhabitants on the big island of Hawaii that eruptions could start once again with little to no warning. I am doing this because I genuinely feel the drop in the alert level from orange to green means all is calm, was kind of premature. I do support the USGS in the research they conduct and the observatories they maintain. However, I'm a little iffy on a couple of the things that the Hawaiian Volcano Observatory has said. Whether intentional or not, the drop in the alert level and temporary lull in seismic activity has likely created a sense of complacency for some living on the big island of Hawaii. I don't think everyone is complacent, however, as there are still many people that are wary of returning to their homes that were surprisingly spared by the devastating effects of the 2018 lava flows. Also, despite what you hear and what you think, there are good people who work for the HVO. Not everyone is holding a piece of duct tape waiting to paste on the mouth of anyone who talks. This isn't meant to bash anyone. I'm simply voicing my concern, and I do think HVO does a great job with their research. The only thing is, I wish they showed more plots to visualize what is occurring rather than just telling people. Regardless of your position on the matter, I highly suggest that you take a look at some of this data. I will present my opinions as well, but no, I am not trying to tell you what to think. Please just look at the data with no bias and you be the judge. As most of you already know, probably, Hawaii experienced one of its most devastating volcanic eruptions in decades if not centuries. Thank God, nobody was killed, but many were injured and countless homes were destroyed. The mid to late 2018 eruptions on the south-southeast section of the Big Island of Hawaii were caused by massive amounts of magma shifting from the Kilauea volcano's magma reservoir. This massive shift caused the entire caldera to collapse over the next few months, causing over 60 explosive eruptions at the Kilauea summit within the now plugged Halimamau lava lake. The draining of the lava lake was the first sign that magma was retreating towards somewhere new. Pu'uo'o even collapsed as well, and thousands upon thousands of earthquakes rocked the entire area, with the largest being a magnitude 6.9. Magma shifted towards the Lower East Rift Zone, right where a great many people reside. Now, I don't want to do a whole recap of the situation since a lot of you probably already know about it, but if you want, you could come to this page here. This is the 2018 Kilauea Lower East Rift Zone page on my website. Under the seismic events drop-down menu, by event, Kilauea LERZ eruptions, right there. This shows some seismic plots of certain events during the entire 2018 eruptions. Of course, it doesn't show everything, but it should help some people understand what was going on. Now, before I get into the data I'm going to show in this video, I want to show people why I think the Hawaiian Volcano Observatory might be correct about some things, but might also be wrong about one thing, just a wee bit. Overall, as you are about to see, uplift is occurring at a far larger rate than seen before the eruptions of 2018. However, seismicity has not been too crazy, so then why is uplift occurring more drastically than before the eruptions? As you are about to see, HVO says that uplift is occurring, but it's minimal. I, of course, am no professional, but I have been studying this stuff for a while, and it does not seem minimal to me. I am not saying that an eruption is going to happen next week or next month. However, the amount of uplift occurring is concerning, making me think that we will see some type of renewed volcanic activity in months, not years. That is just my take on the increased swelling of the middle and lower parts of the Kilauea East Rift Zone. As of the time of writing this is the most recent volcano update on volcanoes.usgs.gov for the Kilauea volcano in Hawaii. HVO summary. Kilauea volcano is not erupting. Monitoring data over the past 9 months have shown relatively low rates of seismicity, deformation, and gas emission at the summit and East Rift Zone, including the area of the 2018 eruptions. Yes, low rates of seismicity and gas emissions, yes, they are pretty low. But deformation, I do not believe it's low, as you're about to see in a second. As of March 26, Kilauea volcano is at normal green. Despite this classification, Kilauea remains an active volcano and it will erupt again. Although we expect clear signs prior to a return to eruption, the time frame of warning may be short. Yes, guys, it could all of a sudden spike in activity any day now, any week now, any month now, and possibly only take a few days to lead to an eruption, just like what happened in 2018. Observations. Monitoring data revealed no significant changes in volcanic activity over the past week. On the morning of May 1st, webcam images revealed a part of the crater rim on the north side of Pu'u'o had collapsed. The GPS data had been showing motions consistent with rim instability for several weeks, so this collapse is not interpreted to be associated with a magmatic activity. I agree with that. That is true. Generally low seismicity, yes, continues across the volcano, with earthquakes occurring primarily at the summit and south flank regions. The largest Kilauea earthquake over the past week was a magnitude 3.3 event on May 3rd, approximately 4 kilometers south of Pu'u'o at a depth of 7.5 kilometers below ground level. USGS received 18 felt reports for this earthquake, which was likely an aftershock of larger earthquakes nearby over the past year. GPS stations and tilt meters continue to show motions consistent with refilling of the deep East Rift Zone magma reservoir. Yes, that is correct. But they do not state how severe it is. Up here, you can tell they said low rates of seismicity deformation, so they're stating to the public that the deformation is low. It's still causing uplift, but they say it's low. That is one thing I do not believe, as you will see in a second. A common deflation-inflation event began at the Kilauea summit on May 4th, which saw 2 days of deflationary tilt before transitioning to inflationary tilt last night. This behavior is normal and has been observed at the volcano for many years. SO2 emission rates from the summit and from Pu'u'o remain very low. So it does seem, guys, that they are correct. Their recent update seems to be pretty accurate, except for one thing, the deformation. Again, they say low rates of seismicity and deformation. Around Pu'u'o, the Middle East Rift Zone, and also parts of the Lower East Rift Zone, uplift is occurring at a much faster pace than it ever did prior to the 2018 eruptions. I mean, maybe it did decades ago or something like that, but for a few years prior to the 2018 eruptions, it seems a lot greater, which I find is very strange. As I'm about to show you via the following GPS plots, most of these areas barely saw any uplift at all prior to the 2018 eruptions, even some areas seeing overall subsidence prior to the eruptions. I don't know why they don't state this in their updates, seeing that aspect of deformation is crucial for notifying local residents of possible hazards. However, I must say seismicity is extremely low compared to the amount of uplift that is occurring, something that has me very, very confused. I just wanted to make this video to warn people that eruptive activity is not over and could begin at any time, likely sooner than we think. Here I'm going to show a GIF image showing 10-day increments of all magnitudes reported by HVO and USGS from January 1st, 2019 through April 30th, 2019. This will show you the progression of seismic activity for the Kilauea and entire East Rift Zone volcano. So you can see there is not really any general location of concentrated seismicity, well, except for at the Kilauea summit. For each 10-day period, let's see how reported seismicity progressed. The date range of the data that you are about to see is the same date range as shown in this animation from January 1st, 2019 through April 30th, 2019, 10-day increments. Here is each 10-day increment from January 1st, 2019 through April 30th for all magnitudes reported. We see seismicity actually seems to be dropping somewhat. You notice that? It seems to be breathing, but overall it does seem to be slightly dropping. That is very strange, especially since uplift is much greater now along the East Rift Zone than it was prior to the 2018 eruptions. However, let's check out the largest magnitude for each 10-day increment. So here's the same date range, but instead it shows the largest magnitude reported for each 10-day increment. Contrary to the chart that I just showed, it seems magnitudes are increasing. That is very peculiar. So we're seeing a slight drop in overall seismicity since January 1st through April 30th, but the earthquakes are getting larger? I don't know. I'm just presenting the data. That would be weird though. Less earthquakes but stronger ones? I wonder why that is. With all the uplift going on throughout the East Rift Zone, you would think seismicity would be much higher than it actually is right now. Now why don't we take a look at some of the GPS data for Hawaii, which is the main course of this video. Here we are at the UNR GPS map, which will show GPS plots and station locations for every GPS station on the face of the entire planet. Again, a link will be provided in the description box below. It's a wonderful tool, but it shows all-time plots. For the plots that you click on, notice here it shows all-time ever since the instrument was installed. I didn't want to see that. I wanted to see my own date range, so I had to create my own plots, as you'll see in just a minute. But this is the location of the first station we will use. Notice we have Kilauea right here, Halimamau right here. Obviously, it looks a little bit different now since it's collapsed. CRIM is the station I will use. Notice it's on the southern rim of Kilauea Caldera in Hawaii. This is a scatter plot of vertical uplift subsidence GPS data for CRIM, which resides on the southern edge of Kilauea Caldera. NA12 reference frame is used here. I thought NA12 was only for the North American plate, but I guess it is also used in other areas to eliminate the natural motion of the plates. Again, this shows uplift subsidence patterns from January 1st, 2017 through April 30th, 2019. Almost 2.5 years worth of data. Measurements on the left are in meters, and each section from line to line is a total of 0.5 meters. In other words, 500 millimeters or 50 centimeters. We see there was indeed swelling of Kilauea prior to the eruptions of 2018. Once the eruption started, boom! Notice we see a big dip right here, totaling around 2 meters or so, possibly more than that. Other stations showed this dip as well, so this is not a glitch. This was actually because of all of the magma in the area left and quickly intruded under Leilani Estates in the lower East Rift Zone. It actually shifted so fast within just a couple days. It was very fast, guys. Magma can literally pick up and go anywhere. If you ever hear someone say, oh, a volcano can't sprout in Los Angeles, a volcano can't sprout under Tokyo, a volcano can't sprout under Seattle, well, if you have magmatic sources nearby, it's very possible it could. But if you don't have volcanoes for tens and tens of miles, maybe even 100 miles away, then you might be safe. But really, magma is everywhere down there. No matter how far down you go, you're always going to reach magma, depending on how far down you go. So, really, volcanoes can sprout up anywhere. You just got to keep an open mind when you're a volcanologist. Now, once the eruptions calmed, right around this area, notice subsidence. Overall steady subsidence has continued. This is contrary to what is occurring along the entire East Rift Zone. So it does not look like Kilauea itself is witnessing a refill of magma. However, the East Rift Zone is. The next eruption, I bet, will not be at the Kilauea summit, but will either be at the lower East Rift Zone or the middle East Rift Zone. Now, here's the same station and data as the scatter plot that I just showed. Again, vertical uplift subsidence is shown. However, this one shows data from August 15, 2018, right when the eruptions started to calm, through April 30th, 2019. As we can see, there's currently no uplift at all, suggesting Kilauea itself is not seeing a resupply of magma. Since November 22nd, 2018, there has been around 50 millimeters of subsidence at the most. That number is a rough estimate and could be greater, could be smaller, but right around there. Now let's take a look at the closest active GPS station to the lower East Rift Zone. Here we are back at the UNR map. Let's zoom in, shall we? Now we see up here we do have some in the lower East Rift Zone, but notice 2009, ended in about 2009, 2010, yeah. And if we go up here and click out of it, you'll notice there's another one up here, same thing as well. So, we do not have any active GPS stations in the lower East Rift Zone. The closest one is right up here, just west-southwest. Actually, I'm going to say more west of Leilani Estates. And this is the location of Station Joka. As you're about to see, this is the closest active GPS station to the lower East Rift Zone. Here is GPS deformation data for Station Joka. Again, this is vertical uplift subsidence from January 1st, 2017 through April 30th, 2019. NA12 reference frame, UNR Analysis Center. Measurements on the left are in meters, and in each section from line to line is a total of 0.1 meters. In other words, 100 millimeters or 10 centimeters. We see prior to the 2018 eruptions, there was some very slight overall inflation. Very almost steady, almost non-existent, but at the end, there was some very slight inflation. Then, once the eruptions began, boom! There was approximately 600 millimeters of subsidence recorded by the station, in other words, 60 centimeters. That is a large drop. Once the eruptions began to calm in mid-August, notice right around this location right here, there was some calm for probably about a week or two, and then a large spike in uplift, as you can see right here, with continued uplift still being recorded, though not as great as the inflation right here, but still, you could tell, notice prior to the eruptions, right now, you can tell inflation is much greater. That is very intriguing that uplift right now would be worse than it was prior to the eruptions. So let's take a closer look. Now here's the same station and data that I just showed, again showing vertical uplift or subsidence. This is from January 1st, 2017, all the way to right when the eruption started. We see there really was not too much overall of a change except for a very slight inflationary trend, possibly starting about 6 months or so prior to the eruptions of 2018, but overall we really don't see too much of a change. Now here's the same data from the same station, JOCA, still showing uplift subsidence patterns, but from August 15, 2018, right when the eruptions calmed, through April 30th, 2019. We can blatantly see uplift has been occurring at a much larger rate than was ever seen prior to the 2018 eruptions. Around October 2018, uplift has not been as severe. As you can see right here, it was going very large spike, and then pretty much steady ever since then. And again, it was not as severe as the uplift we saw right here, but is still quite substantial in my opinion. I have no clue why this has not been stated by the Hawaiian Volcano Observatory and USGS. Maybe it has been, but not openly to the public like on their alerts. I think it is best to always show people the data to warn them about possible future eruptions, even if people might not understand the data. So again, as we can see here, uplift still continues for the entire East Rift Zone, so much so that I bet there is a lot of magma being resupplied under these areas. However, I think it is odd seismicity is quite low compared to how high uplift has been. If uplift continues, the lull in seismic activity will not last long. Since November 22nd, 2018, there's been approximately 35 to 50 millimeters of uplift, possibly even more, since that is a rough estimate. To me, it seems this is the area seeing the largest amount of uplift out of all the GPS stations I saw. But let's check out how uplift is occurring farther up the East Rift Zone in between Pu'u'olo and Kilauea. And just for comparison, again, this is JOCA. After the eruptions calmed, again, we could see increased uplift, in my opinion, substantial. And this is before the eruptions, January 1st, 2017. And right here, the last data point is May 1st, 2018, right when the eruptions started. As you can see, going back, you can obviously see a distinctly different pattern. After the eruptions, a lot of refilling going on of the East Rift Zone. Before the eruptions, barely anything at all. And again, you can see that here with before the eruptions, during the eruptions, and after the eruptions. Here we are back at the UNR map. We have already looked at CRIM on the southern edge of Kilauea caldera, JOCA, which is the closest GPS station to the lower East Rift Zone, and now we're going to look right in the middle, basically, right here. And Pu'u'olo, I believe, is right in this location right here. So it's pretty much right between Pu'u'olo and Kilauea caldera, station MMAU. Now here's vertical uplift subsidence GPS data for MMAU, which resides in between Pu'u'olo and Kilauea. UNR Analysis Center NA12 reference frame. Measurements on the left are in meters in each section here on this plot. From line to line is a total of 0.1 meters, in other words 100 millimeters or 10 centimeters. Data is from January 1st, 2017 through April 30th, 2019. We see that there was a deflationary trend being recorded by the station far prior to the 2018 eruptions. Once the eruption happened, boom! We see large subsidence, just like we did on all of the other GPS stations that I showed. Then notice the data since the eruptions calmed. We see an obvious inflationary trend consistent with swelling from the resurgence of magma underneath the East Rift Zone. Uplift is not as great here, as it is closer to the lower East Rift Zone. For example, Joka, the station I showed just prior to this, is showing uplift is much greater. But the closer you get to Kilauea, it seems the inflation gets smaller and smaller. So I believe the lower East Rift Zone is where it's refilling, right underneath there. So again, I find this very interesting, and the next eruption in this area will likely be somewhere in the middle and lower East Rift Zones. And according to the data, there is a lot of magma coming in, guys. Remember, only a small percentage of magma was ejected during the 2018 eruptions. Of course, the lava flows and fountains put out an insane amount of magma from below, but it still was only a fraction of the amount of magma that is currently down there. Meaning that this could be new magma coming into the East Rift Zone system, adding to the magma that is already there. However, once again, I must state odd seismicity is so low for this area compared to how substantial the uplift has been. To me, that doesn't make any sense, but we obviously see that's what's happening. So what do you think? Let me know below, but let's take a closer look. Now here's the same station and data that I just showed. Again, uplift or subsidence. However, this one shows data from January 1st, 2017, all the way to 1 day before the eruption started in mid-2018. We see a blatant deflationary trend the entire way through the plot. However, around February 2018 or so, right around here, it is possible uplift started just a tad. But still, we see uplift after the eruptions is much greater than before the eruptions, something that HVO has not stated or told local residents. Now here's the same station and data, again, vertical uplift subsidence. However, this is from August 15, 2018, right when the eruptions started to calm, through April 30th, 2019. Each section from line to line is a total of 20 millimeters, in other words, 2 centimeters. We see it actually seems to have been steady for a few months, and then right around mid to late November 2018, that is when we started to see uplift again. However, uplift is not as great here as it is closer to the lower East Rift Zone. I'm going to put my money on the area around Joka, the station I showed prior to this one, as being the location of the next eruption, but possibly closer to the lower East Rift Zone. I don't know when that will be, but uplift is pretty substantial in that area, and all of this calm will not last long if this uplift continues. But how long is long? Nobody can tell you for sure, and I don't know the strength of the rock and the topsoil in that area. But if you live on the Big Island of Hawaii, please be ready to evacuate your home in the blink of an eye. We see from November 22nd, 2018 through April 30th, 2019, there is somewhere around 35 millimeters of uplift. Again, which is smaller than the amount of inflation shown on Station Joka. Now, just for fun, let's take a look at recent deformation for Mauna Loa's summit. As you can see, here's the summit of Kilauea, Halemaumau crater, and here is Mauna Loa right here. Let's take a look at Mauna Loa's summit, the recent deformation since January 1st, 2017. We will use this station here, GPS station MLSP, which resides basically right on the southern rim of Mauna Loa's summit. Now here is vertical uplift subsidence GPS data from station MSLP, which resides on the southern section of the summit of Mauna Loa. UNR Analysis Center NA12 reference frame. Measurements on the left are in meters, and each section from line to line is a total of 50 millimeters, in other words 5 centimeters. This is from January 1st, 2017 through April 30th, 2019. We see deformation in Mauna Loa was unaffected by the 2018 Kilauea LERZ eruptions. Mauna Loa has been inflating for some time now, as you can see here. However, uplift seemed to have stopped for a few months right here and then started back up again around November 18. It is interesting to note uplift is greater since November since it was prior to that. Notice the angle of deformation, steady uplift, and then it stalled, and right around November or so, boom, it's occurring. It looks like it's occurring at a greater rate than it was prior to this. Just a little bit more. That is kind of what we see along the East Rift Zone, most notably near the lower East Rift Zone. So Mauna Loa and the Kilauea East Rift Zone is seeing increased inflation. But Kilauea caldera itself is not? Why is that? Is magma being resupplied to both the East Rift Zone and Mauna Loa but not Kilauea? Maybe. It doesn't make much sense though. Regardless of this, we see uplift continues on Mauna Loa at a greater rate than seen from January 1st, 2017 through September 2018. Notice right here, the angle seems to be greater than the angle of uplift right here, but that's open to additional interpretation. Now here's the same station and uplift subsidence GPS data I just showed for Mauna Loa. However, this is for the time period of increased uplift from August 15, 2018 through April 30th, 2019. We can obviously see uplift is still occurring at Mauna Loa, however again at a rate slightly greater than what we saw prior to the increase of inflation after the pause of uplift. Remember, there's a few months prior to this where it sort of paused. Since November 22nd, 2018, there's been approximately 25 to 30 millimeters of uplift. That is a rough estimate and is open to additional interpretation. However, this is pretty interesting, guys. Well, that is it, folks. I really wanted to put all this information and data out there, seeing some of the in-depth aspects of deformation are not being shown to the public by USGS and HVO. Of course, they are not hiding it purposefully, though. That is not what I mean. Otherwise, I would not have been able to access the data myself, right? However, the majority of the public does not know how to access most of this data. That is why I use my website to eliminate the middleman and allow you, the individual, to access the same seismic and GPS data that is used by professionals every day to monitor volcanic and tectonic hazard areas. So in this video, we saw that seismicity of all magnitudes has been somewhat decreasing along the Kilauea summit and entire East Rift zone. However, the magnitudes of the earthquakes themselves seem to be getting slightly larger. We saw that uplift along the East Rift Zone is much greater than it ever was prior to the 2018 eruptions, suggesting there is a new supply of magma adding to the magma that is already there. Uplift seems to be greatest the closer you get to the lower East Rift Zone, and is not even occurring really at all at the Kilauea summit, which I found odd. Also, seismicity is quite low for these areas, even though substantial uplift is occurring, yet another thing that I found quite odd. Mauna Loa has been inflating for some time as well, but uplift seems to have gained momentum since late 2018 and continues to this day. So where is all of this headed? When do you think the next eruption will be and where? I put my money on the area around Station Joka, possibly more to the east, towards the lower East Rift Zone, since it is seeing the greatest amount of uplift, at least in my opinion, from the stations I saw. This video was full of geodetic data. Know that I am not a professional, and geodesy, the study of how the earth beneath us shifts, is not my main field of study. Of course it is paramount, and it is important in volcanology, but I'm more of a seismology guy. I hope this video helped people understand the changes that have been occurring on the Big Island of Hawaii in regards to recent deformation. As HVO states, seismicity and degassing is low. However, deformation is not low, and I believe it is quite substantial. So I still don't understand why they did not state that. But regardless of this, please be prepared and heed the instructions of local authorities, including HVO and USGS, if eruptive activity begins and you live on the Big Island. I urge you all to learn how to study GPS and seismic data to keep an eye on the many volcanoes worldwide. If there was a mistake anywhere in this video, please let me know in the comments section below. I hope you all stay safe, and the people of the Big Island of Hawaii are in my prayers. God bless, and see you later.